Risk and testing. We have mentioned before how risk is an important factor in the testing activity. We base our testing efforts upon the amount of risk in delivering the product too early. If the risk is high, then we need to spend more efforts in testing the software. If the risk is low, then enough we can deliver the software now. But what is risk after all? Risk can be defined as the chance of an event, hazard, threat, or situation occurring and resulting in future negative consequences or a potential problem. My friends who are PMP certified might not like these definitions, because in PMP a risk may result in future negative or positive consequence, but people in ISTQB consider risks as only may result in future negative consequences. Risks are used to decide where to start testing, where to test more, making some testing decisions, and when to stop testing. I will try here to give you a risk management course in 5 minutes. You might not need to fully understand it for the exam, but the whole idea will make other concepts more clear. Risk management involves the following activities: risk identification, trying to figure out what risks we might face; risk analysis, which involves assessing the identified risks and determining which risks are more important to deal with; risk response, implement actions to deal with those risks. First, we will talk about risk identification. We can classify the risks into two categories: project risks and product risks. What is the difference between project and product? Easy. A product is the software itself. A project is the activities needed to create the product. So product risk is any risk related to the software itself, while project risk is any risk related to how we develop the software. Now, one of the famous questions I have seen is to distinguish between the two types of risks. I even have gotten this question in my advanced level test manager exam. I will tell you here a small trick to help you answer this question. Imagine you are developing a software in your company, say in Egypt, and your customer will be using the software, say in Italy. Look at each event in the question. If the event could happen at your company in Egypt, then it's a project risk. If the event could happen at the client's company in Italy, then it's a product risk. Keep this scenario in mind while looking at examples of both project risks and product risks. Let's look at some examples now for project risks. Project risks include technical issues, problems in defining the right requirement, the extent to which requirement cannot be met given existing constraints, test environment not ready on time, old test tools, low quality of the design, code, configuration, data, test data and tests, and so on, late data conversion, migration, planning and development and testing data. Again, all those can only happen while we are developing the software, so they are project risks. Organizational factors, skill, training, and staff shortage. That can only happen while we are developing the software, so it's a project risk. Personal issues between developers and testers. Political issues such as problems with testers communicating with the developers, failure by the team to follow up on information found in testing and reviews, for example, not improving development and testing practices, improper attitude towards the expectation of testing, for example, not appreciating the value of finding defects during testing. All of these can only happen while we are developing the software, so it's a project risk. Supplier issues, failure of a third party to deliver maybe the hardware on time, or contractual issues with suppliers, vendors, or contractors. And now for the second type of risks, product risks. Product risk is the potential of a defect occurring in the live environment. Examples of product risks are failure-prone software delivered, the potential that a defect in a software or hardware could cause harm to an individual or company, poor software characteristics such as functionality, security, performance, poor data integrity and quality such as data migration issues, software that doesn't perform its intended functions. All of these events can happen at the customer site on a live environment, so they are product risks. Now let's talk about risk analysis. The level of risk or the risk score will be determined by the likelihood of the adverse event happening and its impact. There's an equation that we need to know. Level of risk equals probability of the risk multiplied by impact if the risk happens. So for example, if we have two risks, the first is the risk of having a UI issue. The probability of this risk happening is 4. 4 on a scale of 1 to 5, where 1 is a low risk and 5 is a high risk. But the impact of this risk happens is very low, only 1, using the same scale. Then the level of risk or the risk score for that risk is 4 multiplied by 1 equals 4. A second risk might be a miscalculation in one of the reports. The probability of such a risk is very low, say 2, but the impact of such a risk is very high. The customer will really get pissed off for that defect. So let's say the impact equals 3. So the level of risk equals 2 multiplied by 3 equals 6. So the level of risk for the miscalculation is higher than that of the UI issue, which means that if we have a very limited time for testing, then we would concentrate our effort to test the report to lower the probability of the miscalculation. Prioritizing risk is an attempt to find the potential critical areas of the software as early as possible. Now we have analyzed our risks and prioritized them. I have a problem with this word, so forgive me about that. Then what we need to do now, handle those risks or lower their risk levels. There are 4 ways we can handle or respond to risks. 1 is to avoid the risk. Doing anything to make this risk level equal 0, meaning either making the probability 0 or making the impact of that risk 0. Let's imagine a risk that you have heard rumors that one of your team members, let's call him Jack, might move to another company. To avoid such a risk, you wouldn't assign Jack to your project in the first place and get another one, so the risk will be 0. The second way to handle risks is mitigate. Mitigate means that you will lower the risk level, and you can achieve this by either lowering the probability or lowering the impact of the risk. Well, what do you think we should do with Jack? How can you lower the probability of him moving to another country? We can lower the probability by giving him a promotion or salary increase. Or you can lower the impact by giving him minor tasks to work on. The third way to handle risks is transfer, meaning we should try to move the risk from our side to another side. You might ask Jack's manager to assure you that if Jack left the company, then he would be responsible for finding you another resource with the same qualification, or maybe by outsourcing the whole job to another company. The last method to handle risks is accept. And you can accept actively by putting a plan to be executed in case Jack left the company, like planning for a 2 weeks handover from Jack to a new resource, or you can accept the risk passively by simply waiting for the risk to happen and do nothing and see what's gonna happen. Wow, that was a tough risk management course in 5 minutes or less. Hope it does make sense to you. It's clear that any project risk will later affect the product itself. So the objective of all our risk management efforts is to minimize product risks. A risk-based approach to testing provides proactive activities to reduce the risk levels of product risk as early as possible in the software development lifecycle. Thank you.